Hello friends, today's question: two rods of different material having coefficient of thermal expansion alpha 1 and alpha 2 and Young's moduli y1 and y2 respectively are fixed between two rigid massive walls. The rods are heated such that they undergo the same increase in temperature. There is no bending on the rod. If alpha 1 ratio of alpha 1 to alpha 2 is 2:3, the thermal stress developed in the two rods are equal provided y1 ratio y2 is equal to. So we are given two rods, different materials, and they are in between the walls. So let us have these are the two walls, and this is our rod 1. And this is our rod 2. So we can write this as rod 1, rod 2. Rod 1 is having a expansion of alpha 1. Rod 2 is having expansion of alpha 2, and Young's modulus y1, Young's modulus y2, and this says that they undergo the same increase in temperature. So it means increase in temperature if it is given by delta T, so here it will be also delta T and here it will be also delta T. And it also says that the thermal stresses developed in the two rods are equal provided. It means if the thermal stresses are equal, therefore we can say that thermal stresses is sigma 1 for this one and we have sigma 2 for rod 2. So standard formula, we already know that thermal stress in the rod is given as thermal stress in rod. It is represented by sigma, which is equal to y, alpha and delta T, where y is our Young's modulus of material, alpha is our coefficient of thermal expansion, alpha is coefficient of thermal expansion, and delta T is the change in temperature. Change in temperature. So we have two rods, so accordingly we divide the formula into two parts. We can say that for rod 1, sigma 1 will be equal to y1, alpha 1 and delta T, because delta T is said to be same. And for we have rod 2, sigma 2 is equal to y2, alpha 2 and delta T, and it is given that thermal stress developed in the rods are equal provided. So we say if the thermal stress are equal, thermal stress are equal, which means sigma 1 is equal to sigma 2. We substitute the values, or rather formula, that is y1 alpha 1 delta T is equal to y2 alpha 2 and delta T. So here delta T is same, so this cancels out. So we get here, sorry, this is 1, y1 alpha 1 is equal to y2 alpha 2, and we are supposed to find out y1 upon y2. So we can say that our y1 upon y2 will be equal to alpha 2 divided by alpha 1, and we are given that alpha 1 to alpha 2 is given as 2 by 3. So from here we can say that alpha 2 upon alpha 1 is equal to 3 by 2. So we can write this as 3 by 2. Therefore, the Young's modulus y1, y2 will be equal to 3 by 2, provided, so for this condition, the thermal stress will be equal. Okay, because it says that thermal stress developed in the two rods are equal, provided y1 and y2 are equal to. Okay, we can say for this value, ratio of y1 and y2, thermal stress developed in two rods will be equal. Developed in two rods will be equal. So this comes as 3:2. So we can say that our option number C is the correct option. So you can say that option C is correct. This completes the question. Thank you.